Hello everyone, this is a QuickSort demonstration in Java. Now first I'll start with the main method, talking about only the QuickSort method, while Joseph and Jethusen will talk about the rest of the main method. So first, go down to the QuickSort method with parameters, the array, and the indexes from the first to the last. Now what we put in from above is 0 for A and nums.length minus 1 for B. So that will be the whole array. So this integer number identifies the next sorting, starting point for the next sorting. So that will be discussed in detail later. First, we're going to the partition method, which has the same parameters as the QuickSort method. So going up, now we will want to change the A and B to identify which index is switched with what. So then there will be a left for A and right for B, and this temporary variable will be used for the swapping. Now this is called the pivot. The pivot is the point where the partition is actually going from the left and the right side of the pivot. So then in this case, left is 0 and right is 4. Since total elements is 5, A is 0 and B is 4, so this will be 4 divided by 2, so nums 2, and that's in the middle, so it's the middle element. Now first I would need to compile this and then run. Okay, as you can see here, everything is, well, this one is not really, because this one's mostly sorted already. I only switched like the first two, so then I'm gonna have to run it again. Swap. Well, not many swaps. Okay, this one's more, I think. So I won't be talking about the whole, how it swaps everything, but I'll just give a general idea of how it runs. Okay, so this while loop, this condition is left is less than or equal to right. This would mean that this searches from left to up here. The left would go here and the right would go here, so they both stop at the pivot and they won't cross over. So we know that one part is all less than the pivot and one part is all more than the pivot. Okay, so inside that main while loop there are two separate while loops, and the condition for the first one is pivot is more than nums left. Now since I said earlier left would identify the index number for the array, so 46 is the pivot and 70 is nums left right now, which is 0. So it'll take this number. Since you see here they're comparing the two values. So if pivot is more than nums left, 46 is not more than nums left, which is 70. So this condition, this operation here does not, it won't go. So we go on to the next condition. which is pivot is less than num's right. Num's right starts here, 64. Is pivot less than it? Yes. 46 is less than 64. So then right minus minus. It'll go to the next index, the next element of the array, which is this. Because right would go towards left and left would go towards right. So then it'll be 42, which is 46 less than 42? Well, no, it's not less than 42. So then right would stay at index 3. So we got 0 and 3. Now you're gonna figure out why I actually put these barriers around it. It's to show that they swap. Now you see up here, shows that they swap. I won't go into detail like that. Okay, so about these methods, talk about it later. This condition right here, it will check if left is still less than or equal to right after those operations, because if it is, then that means they're not in the right order. So then they would have to swap it. So you ignore these two for now. What's next is the swapping. This is actually the whole swapping right here. So it would swap num's left with num's right. So num's left is 70 and num's right is 42. You can see right here. Here you see the swapping. Okay, so it'll be, now these two operations, what I did was after the swapping, you wouldn't want the left and right variables to be the same as the swapped numbers. So then instead of the swapping, we would want to get different numbers. So it will be left plus plus, which would be this one index, and right minus minus, which would be index 2. And then whatever happens next, it would compare those two. So what we have now is 0 and 3, and then now it's going to be 1 and 2. So left is 1, right is 2. And then we would go right here. This is the while that it's going to check again. Is 1 less than or equal to 2? Yes, then it will go up. Now, we're going to start from 1 and 2, but the pivot stays the same because it's outside the while loop. So, yes, this condition is pivot more than num's left. Is 46 more than 82? No, it's not. So, left plus plus is, well, pivot is not more than num's left. So left doesn't plus, but then right here, this condition, pivot is less than num's right. Now num's right is 46 right now, and pivot is 46. So is pivot actually less than pivot? No. So these two conditions, they both don't initialize. So here, right, going back here, is 1 less than or equal to 2? Yes, so it's true. It goes into the swapping again. So index 1 swaps with index 2. The elements switch. 82 switches with 46, as you see here in this second row here. 82 and 46 swaps. Okay. And then left plus plus would become 2, and right would become 1. So this condition is not met because 2 is smaller than or equal to 1 is false. So it returns left, which is the index we were talking about earlier. So it returns 2. Now, in order to do this manually, you're gonna have to memorize what the steps, memorize the indexes, memorize A and B, which is actually pretty hard, unless I write it down, that is. Okay, so inside this quicksort method, index would be 2, because this method returns an integer which is left, which is 2. So first it'll look here. Now this is the beginning of recursion. So first I'll give you a brief introduction to recursion, and I'll give you an example as well. So let's just say example. What I'm gonna show you is a brief. It was a question that we had to finish once for some weird. I think it was a assignment question. So it's the factorial. So what this is going to do is, and then we would, okay, so this is actually pretty simple tutorial on recursion as well. So what this does is it would call this method, which is in here, and then all the calculations would be done here in this method. So if none equals 0, return 1, else return none times factorial none minus 1. Okay.